Okay, so the whole gist of this little lab activity was to talk about energy transformations. And in the notes, we kind of defined the energy as mechanical or non-mechanical. Mechanical energy was like large-scale energy. It's a combination of kinetic and potential energy. It's not just kinetic, but we're talking about like the whole soccer ball, an entire person. What is that thing's kinetic and potential energies? If you know those are the mechanical energies of that object. Non-mechanical energy is just a little harder to keep track of. That's where we're dealing with atoms and molecules. Technically, each little type of non-mechanical energy is still a type of kinetic or a type of potential energy. But like I said, we're dealing with small scale, a little harder to keep track of. So those types of energy that we mentioned were light, sound, heat, like thermal energy, electrical energy, chemical potential energy. Chemical potential energy we can find in our muscles, in the food we eat, in batteries, anything that uses electricity, either was directly plugged into the wall or maybe came from chemical potential energy in a battery. So we just want you to think about those different energy transformations that happen in a handful of little toys. Okay, so we'll start with station 1. Okay, so I wanted to show you some of the toys that we had set up for the little energy stations lab. I'm sorry you guys can't do it, but it's pretty short and sweet, so I'll just show you what we got. For station 1, we were talking about the energy that was like inputted into these following toys, and what did you get out? So we have a little clapper. Seen some better days, but it just works like this. So obviously I need to shake the clapper. The clapper in turn then moves itself, and certainly you could hear that. So think about the energy transformations there. We got the toy cell phone. Got to turn it on. Hello? Got some lights, got some sound. Think about how we were able to create that. And our lovely little cash register, which does make some sounds. And we got, of course, some lights. Can scan things, fun times. Okay, so those are the toys for station 1. All right, here are a couple little gadgets for station 2. Just had some little wind-up toys. We got our little monkey. Maybe wind him up a little more. Got our little car. But in either case, I had to do something first. I had to wind it up. I had to pull it back. I certainly need to put some energy into this system. And then in either case, there's sort of some type of elastic potential energy, some spring potential, perhaps an actual spring, or maybe some wound up piece of metal that uncoils back to its natural position. Property of elasticity means something can change positions but is going to try to return to its original position. So some sort of type of elastic or slash spring potential energy is involved in little wind-up toys like this. Okay, station 3 deals with a couple instruments. These are either brand new or I've sanitized them. But there's, of course, stringed instruments, but a lot of instruments simply work by the movement of air. We got a little party noisemaker, a little harmonica, and a little recorder. I'm sure Mr. Langdale would have been proud of me. But in all the cases, of course, I need to create a movement of air. That air creates a vibrating, sound wave inside the instrument. So the air in the instrument is moving, then that air moves towards the microphone in that camera, played back in your room, and you hear it, vibrates your eardrum. But it's all about moving air for musical instruments like these. Station 4 is about the food that we eat. Obviously, we need to eat food to have some energy in our own bodies. But where does that energy come from? Well, there's definitely some chemical potential energy in the food we eat. Think about how this apple grew on a tree. Where did that tree get its energy from? Well, definitely from the sunlight. And also there's chemical potential energies in the ground. This apple grew out of nothing. Well, not really. There was nutrients that came out of the ground that the tree soaked up, absorbed, used a little photosynthesis to create chemical potential energy in this apple. I, of course, need to move my mouth to eat it. So there's some mechanical energy there. And then this energy will get stored in my muscles, also as chemical potential energy. Okay, station 5 deals with this cool thing. It's called the radiometer. Sometimes it's called a light mill, like a windmill, but a light mill. It has these little metal vanes that spin around like a windmill. They have a black side and a white side, and it's in this glass ball here, which is not a total vacuum, it's a partial vacuum, so there are some air molecules inside there. So we're going to see what we need to do to make it move. So first I'm going to use my little fan. Doesn't do anything, certainly a little breeze right here, but it's just hitting the outside of this glass ball, doesn't really do anything. All right, and then we'll try some actual light. Pretty neat, starting to spin. And I'll zoom in so you can see this a little better. But the spinning, the black side is retreating from the light. And this is related to temperature changes. Black is going to be more absorbent of this radiant energy, this light energy. I know we haven't talked about waves and light in the electromagnetic spectrum yet, but visible light is a type of radiant energy. And the molecules on the black side of these little vanes are moving around faster than the white side, so they're a little warmer on the black side. Researching this a little bit, this also has to do with the air molecules inside the glass. So the air molecules get warmer near the black side first, a little cooler on the other side. That creates a pressure difference, kind of like an airplane. The air moves faster across the top of an airplane wing, so therefore there's lower pressure there and creates a little lift. That's Bernoulli's principle. Similar effect here. And we'll also try with the heat. So it stopped spinning now. Here is just a hair dryer. You might think this won't work because the fan didn't work, but this is also producing some heat, which the fan was not. So that heat, radiant energy, maybe infrared light, also creates a spinning motion here with the radiometer. Let me zoom in so maybe you can see that a little better. Okay, here's our radiometer. Hopefully you can see it a little better now. It's actually spinning the opposite way the light will make it spin, so let's see if we can get it to slow down, stop, and reverse directions where the motion is retreating from the black side. Oh, instantly stopped. And now we got it spinning the other way. So that's the radiometer. All right, here's some of the toys and things that go along with Station 6. Here's a little solar duck. Needs a little radiant or light energy. And we have some motion, some mechanical energy from the duck itself. We have our little Easley High School flashlight, which all I have to do is squeeze right here. It's not great, but that is sort of a small version of a generator. And here's an example of a generator. When we study electricity and magnetism a little later, there's 3 keys to electricity, to creating electricity. You need a coil of wire, magnets, and motion. So we got some magnets, coil of wire inside, and my motion can move the wires inside the magnets. and clearly we create electricity. So there is a sort of a small version of that happening inside this little hand generator flashlight. All right, we got our little battery operated radio. Little country. And we have the ever fun little toy caterpillar, battery operated. Okay, so think about the energy transformations in those toys. Okay, and the last station just deals with some electrical devices. We have the electric pencil sharpener. Electricity is going to move a little motor, going to spin some little razor blades, sharpen your pencil. We have our iron, which would ultimately get warm. You could iron out some wrinkles in your clothes. And of course a light. But none of these are battery operated. These are all use electricity, but they all just plug directly into an outlet. Okay, think about the energy transformations in this station.